Hello everyone! So welcome to our lesson for today. Today we're going to take up about common multiple and the least common multiple of two numbers, or what we call as the LCM. And to find the least common multiple of two numbers, or the LCM, we can use any of the three methods. So we have the listing method, prime factorization, and continuous division. So you can choose any of this method. Anyway, I will teach you all the methods, these three methods, and you can choose which method is easier for you to use. Okay, so number one, we're going to find the least common multiple of 6 and 12 using these three methods. Number one, using the listing method. The first thing that you're going to do is you're going to list down at least 5 or 6 multiples of 6 and 12. So it means that you're going to write this using skip counting. So let's begin. We have 6, 12, 18, 24, 30, 12, 24, 36, 48, and 60. So after listing at least 5 multiples of these two numbers, you're going to encircle the common multiple. So when we are talking of common multiple, a multiple that is common to the two numbers, or we can say that the multiple that you can see in 6 and 12. So that is 12 and 24. So you're going to list down the two common multiples. We have 12 and 24. But since that we are looking for the least common multiple, we're going to have as the LCM, or the least common multiple, as 12. Okay. So now, the first smallest common number that will appear is the LCM. So let's proceed to the next method, which is the prime factorization. So we're going to draw a factor 3 for both of these two numbers. So first, we're going to find the prime numbers of 6. You're going to think of two numbers that if you're going to multiply, the product is equal to 6. So that is 2 and 3. So 2 and 3 are already prime numbers. It means that there are only two factors when it is set. So 2 and 3 are already prime numbers. So you're going to write it here, 2 and 3. Next is we have 12. So think of the numbers that if you're going to multiply, the answer is equal to 12. So let's try 2 and 6. So 2 here, we're going to encircle already because this is already a prime number. And 6, aside from 1 and 6, we can also write here 2 and 3. So 2 and 3 here are already prime numbers. We're going to write here all the numbers that are being encircled. So we have 2 times 2 times 3. Now we're going to get for the common multiples. So we're going to encircle the numbers that are common to them. So 2 and 3. So these two numbers, this one, wait for a moment. So this one, we're only counted as 1. So we have here 2, we're going to write 2 here, and this 3 is also counted as 1. So that's why our the common multiples are 2 times 2 times 3. So therefore, to get for the LCM of that, you're going to multiply 2 times 2 is equal to 2 times 2 is equal to 4. 4 times 3 is equal to 12. Therefore, the LCM, or the least common multiple using prime factorization, is equal to 12. Okay, so let's proceed to the third method. Okay, using the continuous division. So we're going to get for the LCM of 6 and 12 again using continuous division. Okay, so for 6 and 12, you're going to think of a number that we can use as divisor for 6 and 12. So we're going to start from the smallest prime number, which is 2. So if we're going to divide 6 by 2, the answer is equal to 3. And 12 divided by 2 is equal to 6. Now we're going to think of a number again we can use as divisor for 3 and 6, and that is 3. Sorry. So that is 3. So therefore, 3 divided by 3 is equal to 1, and 6 divided by 3 is equal to 2. So since that 1 and 2 has no common factor already, we do not have any number that can divide or use as divisor for 1 and 2. Okay, so this is already our last number. So to get for the LCM of this, anyway, the common multiples of these two numbers are the numbers that we can see here. Okay, so we have 2 times 2 times 3. We will not write down 1 anymore. Okay, so we're going to use 2 and 3 here. So 2 times 2 times 3. And if you're going to multiply this, the answer is equal to 12. Why 12? 2 times 2 is equal to 4. And 4 times 3 is equal to 12. Therefore, the LCM for these two numbers using the continuous division is equal to 12. Okay, so whether we're going to use the listing method or the prime factorization or the continuous division, we will arrive with the same answer. Okay? So, what method do you think is easier for you to use? Is it a listing method? Is it a prime factorization or a continuous division? So anyway, let's have here another example. To get for the LCM of 4 and 6 using the listing method. So what are we going to do? Like for what I've told you a while ago, you're going to list down. You're going to list down at least 5 or 6 multiples of 4. You're going to skip count. We have 4, 8, 12, 16, 20, 24, and so on. So in 6, you have 6, 8, 12, 18, 24, 30, and so on. So you're going to encircle the common multiples. So we have here 12 and 24. We are going to look for the common multiples are 12 and 24, but we are looking only for the LCM or the least common multiple, and that is equal to 12. Okay, so let's proceed to the example using prime factorization. We're going to get for the LCM of 27 and 18. So what are we going to do? We're to draw a factor 3. So for 27, think of a number that if you're going to multiply, the answer is equal to 27. So let's try 9 and 3. So 3 here is already a prime number, so you're going to encircle. So 9, we can still have, aside from 1 and 9, we can still have 3 and 3. So 3 and 3 here are prime numbers. So we can write 27 as a product of its prime factors as 3 times 3 times 3, tatlong 3. Okay, then we'll proceed to 18. So we're going to think of a number that if you're going to multiply the two numbers, the answer is equal to 18. We can use 2 and 9 or 3 and 6. So you can choose any of that. So let's try 3 and 6. So 3 here is already a prime number. So 6, you can use 2 and 3. Okay? So we're going to list down the numbers that are being encircled. Those are the prime numbers. So we have 2 times 3 times 3. Then we're going to encircle their common multiples. Okay? So this one, we're going to count this as 1. And then if we're going to write all the common multiples, we will start from the smallest number. We have here 2. Then we have here 3. Then we have here another 3. And the last one is 3. Okay. If you are going to put that together, 2 times 3 is equal to 6. 6 times 3 is equal to 18. 18 times 3 is equal to 54. That's why the LCM of 27 and 18 is equal to 54. Okay, let's proceed to the last number. 15 and 45 using the continuous division. Okay, 15 and 45. You're going to think of a number that can divide or use as divisor for 15 and 45, and that is 3. here. So 15 divided by 3 is equal to 5. 45 divided by 3 is 15. Then 5 and 15, you can use 5 as divisor. Therefore, 5 divided by 5 is 1, and 15 divided by 5 is equal to 3. So the numbers here are the LCM, are the common multiples, I mean. So you're going to list down 3 times 3 times 5, starting from the smallest number. Do not write 1 anymore. So we're going to write only the numbers which is higher than 1. So 3 times 3 is equal to 9. 9 times 5 is equal to 45. So that's why the LCM is equal to 45. Okay? Did you understand? So I hope you learned something from me today. So that's all for now. We'll see each other again soon.